You are sitting there just staring at your printer.
Oh, yeah. The classic 1,000-yard stare. We all know it.
Right. I know exactly the look you have right now. You're an intermediate maker. You're maybe, 6 to 24 months into the hobby?
Yep. That's usually the timeline.
And you've successfully printed your fair share of standard PLA. Your basic polylactic acid stuff.
Easy stuff, yeah.
Exactly. You've even conquered the nasty stringing issues with PTG, which is polyethylene terephthalate glycol, the slightly stronger stuff everybody loves for functional parts.
You've got the basics down, basically.
Oh, right. You know how FDM works? Fused deposition modeling? The machine melts plastic layer by layer. We get it. But right now, you are looking at your first budget printer, and it is acting up. Again.
It's always acting up.
Right.
Yeah.
Maybe the extruder's clicking, or I don't know, the first layer just refuses to stick to the bed no matter what you do.
Yeah, you clean it 10 times and it still peels off.
So you're facing this classic maker dilemma. Do you keep upgrading this machine, ordering new parts, spending your weekends tuning it, or do you finally just, buy something new?
It's really the defining crossroad of the hobby, I think. Because everyone hits this exact wall once they master the basics.
Yeah.
You start realizing your printer is a project itself rather than, a tool to make other projects.
Oh, man. I feel that in my bones. I really do. And mapping out a true next-level decision framework is basically our mission for this deep dive today.
Sounds good.
We're pulling from two really comprehensive articles from Printar 3D. We have their 3D printer buying guide, budget versus flagship versus DIY.
That's a great one.
And we also have their companion piece, which is this reader Q&A focused entirely on hardware mistakes.
Tons of good insights in there.
Yeah. And the goal here is to make sure you don't overpay for features you'll never actually use. Or, on the flip side, buy a machine you'll completely outgrow in, a month.
Exactly. Because at this stage in your journey, you already know what a 3D printer is. You don't need us to explain the absolute beginner basics.
No, definitely not.
You need a strategy for your next move. And that has to be based on the real mechanics of how these machines actually operate and, frankly, how they fail.
Okay, let's unpack this. I want to challenge the basic premise we constantly hear on forums and subreddits.
Oh, boy. The classic advice.
Right. We always hear that you should just look for the lowest price tag when entering or moving up in the hobby because, struggling builds character or it teaches you the machine.
Right, right.
But for someone who already knows how a Hoden works, is that common advice actually a massive trap?
I would argue it's the biggest trap in the community right now.
Really? The biggest?
Yeah, absolutely. And to understand why, we first need to look at the distinct categories the FDM market actually falls into.
Yeah.
Because a printer's price is just a byproduct of its design philosophy.
Okay.
That makes sense.
Yeah.
So the Printer 3D buying guide breaks the market down into 3 very specific buckets. First, you have the budget class. This bucket offers the lowest possible barrier to entry, usually around $200.
Super cheap.
Right. Second, you have the flagship class. This bucket sells time, reliability, and a tightly integrated hardware and software ecosystem.
Okay, now the third.
Third is the DIY, or kit bucket. That one offers total control, open source architecture, and basically unlimited modification.
Okay, so those are 3 completely different philosophies.
Yeah.
So when we talk about that budget class, what are we really getting?
Well, yeah.
Or maybe I should be asking, what are they leaving out to hit that $200 price point?
Yeah, that is exactly the right way to frame it. The manufacturers have to save money somewhere.
Right.
And the sources highlight that the budget class saves money precisely on the parts that determine hassle-free printing.
Give me some examples.
For instance, they often skip automatic bed leveling. They compromise on the physical frame rigidity. They use lower quality extruder gears, and they completely omit automatic flow calibration.
Wow. Okay, let's break those down because those omissions are the exact things that cause failed prints.
Absolutely.
Let's take frame rigidity. If your vertical aluminum extrusions aren't perfectly square and rigid, you get Z-banding.
The dreaded Z-banding.
Right, and then for anyone who hasn't encountered it yet, Z-banding is when wobbles in the vertical threaded rods translate directly into your print.
Yeah, it leaves those ugly, repeating horizontal lines all over the surface of your model.
It's just awful.
And then you have the lack of automatic bed leveling. Without it, you are constantly fighting the Z offset.
Oh, don't remind me.
The Z offset is that microscopic distance between the tip of your nozzle and the print bed. If it's too high, your first layer looks like loose spaghetti and just peels right off.
Yep.
If it's too low, the nozzle literally scrapes the bed and the plastic jams.
I remember spending hours, like literal hours, sliding a piece of printer paper under the nozzle.
Oh, the paper trick.
Yeah, trying to feel for the perfect amount of friction at all four corners of the bed. It was infuriating.
It really is.
And flow calibration is even worse. On my first cheap printer, I would print like 20 little hollow cubes, measuring the wall thickness with digital calipers, adjusting the extrusion multiplier in the slicer by 1%, and then printing it all over again.
Oh, yeah.
It would kill an entire Sunday. Just gone.
But see, the landscape has completely shifted recently, which is why that buy cheap advice is just outdated now.
How so?
The sources point out that machines like the Bambu Lab A1 and the P1S raised the bar significantly for the entire industry.
Oh, absolutely.
They did this by integrating automatic bed leveling and automatic flow calibration by default.
Wait, how does that actually work mechanically? Because I know they don't just guess.
No, they don't guess at all. They use physical sensors. Instead of you printing calibration cubes, a flagship printer like the A1 uses load cells built directly into the tool head.
Load cells, okay.
Yeah, so as it prints a test line, these sensors measure the actual physical pressure of the molten plastic pushing back against the nozzle.
That is wild.
Right. The machine's computer algorithmically adjusts the flow rate on the fly to compensate for the specific viscosity of whatever filament you just loaded.
So you don't have to do anything.
Exactly. You don't have to buy a probe, splice wires into your main board, compile custom firmware to get this. It's just built in.
I used to think about this like buying a car.
Okay, I like car analogies.
Like buying a budget printer was like buying a project car. It's a fantastic way to learn how a combustion engine works. Right?
Sure, yeah.
You'll learn every single bolt, belt, and wire.
Yeah.
But I'm starting to think that analogy is flawed for an intermediate user.
Why is that?
Because if you just need to commute to work reliably every morning, you do not want to be adjusting the carburetor in your driveway at 6 in the morning in the freezing cold.
No, you definitely don't.
You just want the car to start. I just want to print my custom shelf bracket. I don't want a second job as a machine technician.
Exactly, which means we have to completely reframe what that sticker price represents. Because budget machines skip those crucial sensors and rigid parts, the conversation naturally shifts from the initial purchase price to the hidden running costs.
The hidden costs.
Yeah, these are the costs that catch users completely by surprise once they're a few months into the hobby.
And if we follow the logic, those missing hardware features lead directly to the parts that wear out. Which brings us perfectly to the second article, the Printera 3D Reader Q&A.
Yes.
They spent a whole month answering reader questions about hardware failures, didn't they?
They did. The expert coverage for the month actually spanned 3 distinct weeks of topics.
Okay, lay them out for me.
The first week was all about choosing a first printer. The second week dove deep into maintenance and consumable parts, specifically nozzles, PTFE tubes, and print surfaces.
Right.
And finally, the third week expanded into AMS, which is multi-material printing.
Okay, let's camp out on that second week for a minute. Maintenance and consumables. This is where the true cost of that budget project printer really starts to pile up, right?
Yeah. Oh, big time. The reality of total ownership cost goes way beyond the $200 purchase price you see online.
Obviously.
It includes your ongoing filament consumption, of course. Every failed print due to a bad Z offset is wasted plastic.
Just money in the trash.
Yep. But it also includes replacing spare nozzles, buying a new build plate when you inevitably gouge it, and a massive amount of your own time spent tuning the machine just to keep it running.
The Q&A article had a really great specific example about nozzles that perfectly illustrates this. We have to talk about abrasive materials like carbon fiber.
Oh, that is a classic trap. So as intermediate users advance, they want to print stronger functional parts.
Right, they want to make drone frames or whatever.
Exactly. So they buy these advanced abrasive composite materials like carbon fiber filled PTG, and they try printing it with the standard brass nozzle that came on their cheap budget printer.
I always try to visualize what's happening inside the hotend when they do that.
It's brutal.
It is. Carbon fibers aren't just like black dye. They're literally microscopic shards of incredibly hard material.
Right.
When your extruder motor pushes those glass or carbon shards through a heated brass nozzle at high pressure, they act like sandpaper.
They really do.
They scrape the inside of the brass bore with every single millimeter of extrusion.
And the physical wear is shockingly fast.
Like, how fast?
Well, the source notes that if you print abrasive composites with a standard brass nozzle, the bore will widen in literally just tens of hours of printing.
Tens of hours, that's nothing.
It's nothing. Your precision 0.4 millimeter nozzle quickly becomes a sloppy, oval-shaped 0.8 millimeter nozzle.
Oh, man.
The lines get messy, the fine details are lost, and stringing becomes totally uncontrollable.
Right.
You absolutely need to buy a hardened steel or tungsten carbide nozzle for those materials, which is an extra cost.
And people see their print quality degrading, and they run straight to Reddit to complain that their printer is garbage.
Oh, constantly.
Are users unfairly blaming their printers for failed prints when in reality, they're just using worn-out consumable parts?
Yeah, a lot of the time.
Because it feels like throwing away a perfectly good power drill just because the drill bit got dull.
That is a very accurate way to look at it. They absolutely blame the machine for a consumable failure. Let's look at the print bed as another example.
Okay, sure.
Most modern printers use a PEI sheet, which stands for polyethyramide.
Right, the gold or black flexible plates.
Exactly. It's a spring steel plate coated in a textured plastic that grips filament when hot and releases it when cold.
Magical stuff, honestly.
It is. But if that PEI surface is contaminated with microscopic oils from your fingers, the print will not stick. It will fail on layer 1.
Just from touching it.
Yep. Wash it with dish soap and it works perfectly. But buyers mistakenly see it as an expensive fundamental flaw with the printer's leveling system.
Or they blame the extruder when it's actually just an aged PTFE tube. Let's define that for a second.
Good.
PTFE is polytetrafluoroethylene. It's basically a slippery Teflon straw.
Yep.
In a traditional Bowden system, the extruded motor sits mounted to the frame of the printer, and it pushes the filament through this long PTFE tube all the way to the hot-moving print head.
Right. And over time, the heat from the hot end degrades the very tip of that PTFE tube.
The part touching the heatsink.
Exactly. It chars slightly, the inside diameter shrinks, and the friction increases massively.
So it clogs.
Basically. The extruder motor tries to push the filament. It hits that high friction zone, and the motor gears just click and grind the filament to dust, causing severe underextrusion.
And again, a replacement tube costs what, a few dollars?
Yeah, it's a consumable. But to a frustrated user, it looks like a catastrophic machine failure.
Okay, so if we know that true cost includes your time, the wasted plastic from failed prints, and constantly replacing cheap consumables that wear out, how do you actually make the choice then?
Right.
How do you decide between sticking to a budget machine, building a DIY kit, or making the jump to a flagship ecosystem?
Well, the printer 3D sources lay out a very clear decision matrix for this scenario.
Okay, let's hear it.
It's an order of operations. You must define your specific use case first.
Meaning what?
What are you actually trying to make? Toys. Brackets.
Okay, got it.
Then you look at the physical print volume you need. Then you look at the chemical materials required for those parts. And you look at price last.
Looking at price last feels entirely backwards to how almost everyone shops for consumer tech.
It really does.
Usually, you set your budget first and see what fits inside it.
It feels backwards, but in 3D printing, it's the only way to avoid the traps we just broke down.
Okay.
Let's frame this as a clear decision guide based on the sources.
Okay.
You should choose a flagship machine like the open frame Bambu Lab A1 or the enclosed P1S when you want functional parts and reliable output right now.
When you just want it to work.
Exactly. You make this choice when you decide you value your time over tinkering. You just want the part in your hand so you can finish your actual project.
What about the other side of the coin? When does the budget or DIY route actually make sense?
You should stick with a cheap open frame machine or a DIY kit when you actively want to learn the deep mechanics of the hobby.
Okay, so when the printer is the hobby.
Right. You choose this route if you want to tune the flow yourself, you want to learn how to compile firmware, and you honestly don't mind spending your evenings calibrating the machine instead of printing final parts.
If the machine itself is your hobby, buy the kit. Makes total sense.
Exactly.
Let's go back to step 3 of that matrix for a second. The materials dictate the hardware. We touched on abrasive materials needing hardened nozzles, but it goes way beyond that, doesn't it?
Oh, absolutely. The physical environment of the printer is dictated entirely by the plastic chemistry.
Okay.
The sources specifically note that if your materials list includes things like ABS, which is acrylonitrile butadiene styrene,
Right.
or ASA, which is its UV-resistant cousin, an enclosed machine like the P1S is absolutely necessary.
And we should explain why, because it's pure thermodynamics.
It really is.
As ABS plastic cools from its printing temperature of, 250 degrees Celsius down to room temperature, it shrinks It contracts significantly.
Tremendously.
If you print ABS on a cheap open-frame printer, the ambient air in your drafty room cools the upper layers of the print much faster than the heated bed cools the bottom layers.
And then chaos ensues.
Exactly. The plastic literally pulls against itself as it shrinks. The upper layers contract and curl, pulling the corners of your print up and off the bed with incredible force.
It's true. It will literally rip chunks of glass out of a glass bed.
I've seen it happen. It's terrifying.
That's why the P1S has an enclosure. It traps the heat, holding the ambient air around the print at a steady 45 to 50 degrees Celsius, so the entire part cools down slowly and evenly once the print is finished.
Okay, I'm going to pause our conversation right here because I want to deliver the most actionable tip of the week for you listening right now.
Ooh.
All right. This comes directly from synthesizing these two articles. If you are leaning toward buying a budget printer because the low price is tempting, do this one math trick before you hit checkout.
What's the trick?
Take the sticker price of that cheap printer and immediately add roughly $100 to $150 to it.
Okay, why that specific amount?
Because that covers the parts you will inevitably buy within the first 3 months.
Ah, I see.
Right. It covers a hardened steel spare nozzle for abrasive filaments, an extra PEI spring steel build plate for when you scratch the first one, and high-quality PTFE tubes to fix the friction issues we talked about.
Yep, the hidden costs.
Then take that real total, your initial price plus the $150, and compare it against a flagship like the A1 or P1S.
I love that framing because it completely changes the math.
It really does.
Suddenly that budget printer is not looking quite as cheap. When you factor in the consumable parts you're inevitably going to need, plus the value of your own time spent installing them, the gap between budget and flagship shrinks dramatically.
But let's say you run that math. You decide your time is valuable, you buy a flagship, and you avoid the whole hardware tuning trap.
Okay.
You think you're completely in the clear. But expanding that ecosystem brings its own set of illusions.
Oh, sure.
You fix the basic hardware issues, and then you decide you want to print in multiple colors. This leads us to the third week of the Printar 3D series, which focused entirely on the AMS.
Yes. AMS stands for Automatic Material System. It's the multi-material dream, isn't it?
It looks so cool.
It really does. It sits on top of your printer, holding 4 different spools of filament, and automatically feeds them into a single nozzle, switching colors on the fly.
It is the absolute dream. People see the marketing videos of perfectly printed 4-color articulated dragons.
Everybody wants to print the dragon.
Everybody. They get so excited about AMS, and they expect to just load any random spool of exotic filament they have lying around into the system and have it work flawlessly out of the box.
But this introduces a totally new bottleneck.
Let's hear it.
The sources provide a very necessary reality check here. AMS is undeniably fantastic for PLA, for PTG, and for dissolvable support materials.
Right.
If you're printing multicolor toys or complex mechanical geometries that need water-soluble supports to hold up overhangs, it's wonderful.
But there is a massive reality check coming for advanced materials.
Exactly. Let's talk about soft materials like TPU.
Oh boy.
TPU stands for thermoplastic polyurethane. It's basically flexible, printable rubber.
Use it for phone cases or custom gaskets.
Right. TPU will severely jam in the long Bowden bends of an AMS.
I always explain printing TPU through an AMS like trying to push a wet noodle through a really long, curved plastic straw.
That is the perfect way to describe it.
Right. The AMS uses feeder motors at the spool to push the filament all the way down to the tool head. When it tries to push flexible rubber, the TPU just compresses, bends, and binds up inside the tooth.
You get instant jams.
Yeah. You have to bypass the AMS and feed TPU directly into the tool head from above.
Then you have strongly hygroscopic materials like nylon.
Okay, remind everyone what hygroscopic means.
Hygroscopic means the material actively absorbs moisture from the air. Nylon absorbs water extremely quickly unless it's kept perfectly dry in an active heater.
And the physics of wet filament are brutal.
Terrible.
When you feed wet nylon into a nozzle heated to 280 degrees, the moisture trapped inside the plastic instantly boils.
It literally turns into steam.
Yeah, you can actually hear it popping and hissing as it prints, leaving little pock marks and holes all over the surface of your model.
And the critical detail here is that the AMS is just a dry box.
Wait, really?
Yeah, it has some silica gel packets to keep things dry, but it does not actively heat and dry wet filament.
I did not know that.
So if you load a slightly damp spool of nylon into your AMS, it will remain damp and your print will fail.
Wow.
Furthermore, those fiber-filled composites we talked about earlier, like carbon fiber PTG, will heavily wear out the internal plastic feeding mechanism and gears of the AMS itself, not just the nozzle.
Wait, let me make sure I understand the full picture here. So what does this all mean? Does buying an AMS not actually solve your fundamental printing problems?
Whoa.
It sounds like you're just moving the struggle. You're moving the bottleneck from manual hardware calibration over to managing material physics.
That is precisely the insight. Buying an AMS doesn't mean you can ignore physics or chemistry.
Right.
You're no longer fighting a bad Z offset with a piece of paper, but you are now fighting ambient moisture, tube friction, and material stiffness.
So it's not magic.
No, the AMS is not a magic box that makes every single material behave perfectly. It just adds another layer of variables you have to manage.
Which loops us right back around to the decision matrix from the buying guide. Use case, print volume, materials, and then price.
Exactly.
If your specific use case requires lots of soft TPU gaskets or highly abrasive, moisture-sensitive nylons, maybe the AMS isn't the expensive upgrade you actually need right now.
Probably not.
A simple dry box feeding directly into the top of the printer would be vastly more reliable and significantly cheaper.
You have to match the machine and the expansions to your actual physical reality in your workshop, not the marketing fantasy you see on YouTube.
I think we have really unpacked the true cost here. Picking an FDM printer, especially when you're moving up to your second or third machine, is ultimately about matching the hardware to your current phase in the hobby.
Agreed.
It's about acknowledging that your time is a tangible currency. Every single hour you spend unclogging a cheap hotend or replacing a burnt PTFE tube or leveling a warped bed is an hour you are not designing in CAD, you're not creating, and you are not actually enjoying the hobby.
Yeah, I want to leave everyone with a final, slightly provocative thought to ponder, synthesizing everything we've covered from these two sources regarding true costs.
Let's hear it.
If you buy a $200 budget printer and you spend the next 6 months buying replacement parts, printing custom brackets to stiffen the frame, swapping the main board, and modifying the extruder to fix its initial shortcomings, are you accidentally building a DIY printer just without the benefit of a clear blueprint?
Oh, man. That is a dangerous question for a lot of people's wallets. It really makes you rethink that initial $200 price tag. For the full number, see printerae3d.com.